Now we're going to take what we've been practicing with the boxes and working backwards, and we're going to connect it to algebra as far as a way that you don't have to keep drawing those boxes. So we're going to look back at the same examples we've already done, and we're going to start showing you how you can not draw the boxes over on the right-hand side. So looking at the first problem, it was x plus 19 equals 21. So if you drew the boxes, you started with x, you said you add 19 and you would get 21. Well, to work backwards, instead of adding 19, you would subtract 19. Well, how can I show that over here on the problem without drawing all those boxes? Well, I'm subtracting 19 from what, first of all? I'm subtracting it from the 21. So I can write minus 19 underneath the 21. But I'm also kind of taking it away from itself, undoing what I've already know is there, which is add 19. So I'm going to subtract 19 there. I'm kind of subtracting it, if you see it this way, to like both sides. If I draw that line, you don't need to, so I could take it away. That's kind of what I'm doing. You can think of that equal sign as like the tipping point on a scale. So what I do to one side, I do to the other side. Now, let's actually do the math. When we do 21 minus 19 in the boxes, we get x equals 2. Over in our problem, 19 minus 19 is 0, so it kind of just goes away, because 0 plus anything is itself. But I have to bring down that x, the equal sign, and now I can do 21 minus 19, and I get 2. So I'm still getting the same answers. In the next example you already did, it said f divided by 3 equals 11. Same thing over here, f divided by 3 equals 11. And we said, well, how do we undo that? Well, instead of dividing, we're going to multiply by 3. So how do I show that over here? I might rewrite the problem so that I can actually see it as f divided by 3 equals 11 first. And now, I said multiply by 3. Well, I can multiply by 3 by writing it like that. When I multiply by 3 in the boxes, 11 times 3 was 33. So now let's see if we can figure that out over here. Well, in the last problem, 19 minus 19 canceled out because it equals 0. Well, the same thing does happen in this problem. And I want to show you why, and I'm kind of going to do it on the sides because you don't write it every time. So if I have 3 times f over 3, or f divided by 3, I can make that 3 on the left here a whole number that's turned into a fraction. It's still 3, but I'm writing it as a fraction. Now, if you remember your rules for multiplying fractions, I can cross-cancel, meaning I can look on the diagonals and see if I can reduce. If you look on that diagonal, the 3's can both be divided by 3 and give you 1. Well, 1 divided by 1 is 1. And anything divided by 1 is still 1, meaning 1 times f is 1f, and 1 times 1 is 1, and 1f divided by 1 is still f by itself, because remember there's always a 1 in front, I don't have to write it. So again, you don't have to do this every time, but it is there. So these just cancel out. I'm left with f equals 3 times 11 is 33. Still getting the same answers. On a slightly more difficult problem, now we have more than one step we're doing. We have 5x minus 19 equals 26, which when we wrote it with the boxes, we wrote x times 5 is what we would do first, order of operations, and then we would subtract 19 to get 26. Well, let's undo that again. So instead of subtracting 19, we would add 19. Well, how do we show that over here? So I would add 19 to both sides, just kind of like I did over here. I undid it from the top, and I'm going to add it to the 26. And let's do that first. Now really, does it say 19 plus 19? Or does it say negative 19 plus 19? This is where you understanding that a subtraction sign is a negative is really important. Otherwise, you really need to do the add the opposite for yourself. Once you realize that it's a negative, negative 19 plus 19 takes you right back to 0. So they do cancel out. And I can do 26 plus 19 on the right-hand side. But I still have this 5x here, so I'm going to bring it down. And I have 5x equals 45. Now back over to the left side where we were undoing everything. Instead of multiplying by 5, we divide by 5. And when we did 45 divided by 5, we got 9. How do I show the divided by 5 over here? I do divide by 5, divide by 5. 5 divided by 5 is 1. And there's always a 1 in front of a variable, so I don't have to write it. I'm just going to cross out 5 divided by 5, like it cancels out like the negative 19 and 19 does. I'm left with x equals 45 divided by 5 is 9. So again, we don't have to keep drawing the boxes. Now we can start doing some more algebra. In a more complex problem where there's many steps, you still do the same thing, and you just do things to both sides. So we did this problem already in our notes once. I just wrote up the steps at the top there. So first I would subtract 6, then I would multiply by 2, then I would add 1 to get 9. That's order of operations. Now let's do reverse order of operations. Go in the opposite order. So first, instead of adding 1, I would subtract 1 to get 8. How do I show that in the problem down here? Again, I write subtract 1, and do that first. 1 minus 1 is 0, so that goes away, and 9 minus 1 is 8. But now I can bring down everything else, the 2 times the h minus 6 in parentheses. Then up top we said multiply by 2, so the opposite of that would be to divide by 2. 8 divided by 2 is 4. Down at the bottom here, that means I'm dividing by 2 like that. 2 divided by 2 is 1, cancel it out. I'm left with h minus 6 equals 4. And then the last part was to, instead of subtracting 6, we're going to add 6 to get h equals 10. So I am going to add 6. And again, here is another, is it negative or is it positive 6? If you realize that that's a negative 6, then you'll already know it can be canceled out. Otherwise, if you add the opposite, you now see it's a negative 6, and negative 6 plus 6 still cancels out. And when you bring down the h, you get h equals 4 plus 6 is 10. Same answer. Now you're going to do this on the worksheet, do the boxes and the algebra, and hopefully you'll start seeing the connection even more and stop needing the boxes. Good luck!